Hi, this is Tej Arora. I'm an AWS Certified Solutions Architect Associate. In this video, I will review and summarize the framework white paper in the AWS well-architected series of papers. Let me show you which paper I'm talking about. So if you go to the search engine and look for AWS well-architected, the first result looks like the right one. So this is what I'm going to be discussing. There is a well-architected series of papers. Today I'm going to be discussing the framework paper, and as you can see, there are 5 other papers discussing each of the 5 pillars of the framework, and there are also other white papers discussing specific industry segments or specific vertical functionality from the perspective of the AWS well-architected framework. So you can take a quick look at the paper I'll be talking about. This is the paper I will review and summarize in this video. AWS has experience with running cloud scale applications for over a decade. AWS has put the best practices learned from these experiences with solution architectures into this framework. This framework helps evaluate if your existing apps adhere to architectural best practices. If you're building a new app, it provides a structured approach to building it well. Before I begin to discuss the details of this paper, let me just point out that I have a video I made earlier discussing the AWS architecture template. It provides a good framework to understand the concepts discussed here. Please take a look when you can. Here's an outline of what I'm going to discuss. I'm going to quickly go over the terminology used. And these are the 2 main sections in the paper: cloud design principles and the pillars. And finally, I will discuss my own summary of the paper in a condensed form. So these are the terms commonly used in the paper. Component is essentially a software component. It's a technical unit of ownership. Workload is basically a set of components, and this is going to be used quite often in the paper. You understand architecture. Milestone is times when the architecture changes in significant ways, and basically a portfolio is a set of workloads. Now let's look at design principles on the cloud. Stop guessing capacity. In the traditional IT scenario, resources were procured in advance with some amount of fuzzy planning. In the cloud, you can get resources at any time. You can get them instantly, and these resources come from a nearly infinite pool of resources. Test your workloads in an environment that mimics production. You want to be able to observe your system just like your end users would. In the cloud, it's easy to create and set up such environments. You can experiment on innovative ideas easily. There's automation in the cloud to quickly set up environments, and you pay only for what you use during the experiment. Architecture is not a one-time activity in the cloud. There's new features and new services released constantly. Keep an eye on the latest and improve your architecture continuously. Monitor your solution. Is the response time good enough? Is it cost effective? Are there any vulnerabilities? There is a lot of runtime data that's pointing towards potential improvements. And finally, test your production application, just like an end user would. Inject failures in your production system and see how it does. Improve your system and keep iterating. So you follow these cloud design principles in order to ensure that you achieve the pillars for your solution. The pillars are operational excellence, security, reliability, performance efficiency, and cost optimization. I will be discussing each of these pillars in greater detail soon. First, I'd like to share a couple of observations. First is, I noticed that scalability is not one of the pillars. Now, my interpretation of this is that the AWS infrastructure and all its services, they already are very scalable. So building a solution on top that is scalable should not be a big stretch. However, I personally feel that scalability should have been one of the pillars. Perhaps the implication here is that by building a solution that meets these 5 criteria, it should lead to a scalable solution automatically. The other thing I wanted to share is that the pillars, kind of sort of look like design aspects. So, what's the difference between these cloud design principles and these aspects that are also seemingly design aspects? The second point of confusion I had was that each of these pillars is discussed in the context of design principles and best practices. So, this clearly implies that there's design aspects to each of the pillars. However, the design principles of the cloud are a combination of practices and guidelines. So, what does it mean to have design principles and practices separated out under each of the pillars? So, if you'll indulge me, I'd like to use an analogy, and I believe the analogy helps in trying to keep things as clear as possible. This analogy hopefully helps facilitate the understanding of the different aspects. So imagine the cloud, AWS cloud, is a factory of Lego blocks, and you are building a product using these blocks. Let's say you're building a car using Lego blocks. So the design principles, my interpretation of that is it represents 2 things. One is the capabilities of this factory of blocks and some core practices you should follow. And the 5 pillars represent the attributes of the product that you build. So let's look at the analogy for design principles in terms of Lego blocks. So what you have is an unlimited supply of many different kinds of Lego blocks, and you get components from the smallest pieces to pre-assembled parts available on the cloud, and you have high quality, robust, and carefully designed pieces and parts. So you don't have to guess in advance what computing resources you need and how many of them you need. And you should be testing your product in real world conditions, like you would test software at production scale. You can iterate through different product variations and ideas quickly and easily. You can automatically assemble shapes of any kind, like you can do easy experimentation through automation. Now and then, new pieces and pre-assembled parts are available. Keep a watch and be ready to fine-tune your product, like you would allow your architecture to evolve and keep innovating. Observe how the product works over time, and if there are rough edges, fine-tune it, like you would fine-tune your architecture using data. Test your product frequently in real-world conditions, and if it's not meeting requirements, tune it and repeat, like you would improve your solution through testing in production. Now let's look at the analogy in the context of pillars. The pillars are the attributes of the product that you build. Your Lego car must be easy to operate, must be safe to use, it must be robust and not fall apart easily, it must be fast, and it must be cheap. I hope this gives you some idea of the intention behind design principles and the pillars. Now let's discuss each of these pillars in greater detail. Let me quickly outline the structure of each of these sections. Each section has 2 parts: design principles and best practices. Interestingly, in the main part of the paper, the design principles included design guidelines and practices, but in the pillar sections, the practices are separated from design principles. In each case, the design principles consist of a few guidelines which sort of sound like practices, sound like things one must do. And the best practices consists of things to do and the key service or services that enable these practices. The best practices section has a few categories of actions to take, basically a set of things to do organized by major categories, and also a key service that plays a central role to achieve the requirements of this particular pillar. And each of the best practices is structured in 2 parts. One is the set of services that help with the actions in that practice category, and a set of questions which actually drive the best practices efforts. Here's an example. Now, if you put down all the questions related to every best practice in every pillar, what you have is a structured checklist that helps drive actions. Now that you know the structure of each pillar's content, let's step back and discuss each of the pillars. Now, operational excellence is about running workloads, monitoring them, and responding to events most efficiently and continuously improving processes. Let's look at the design principles for operational excellence. Treat operations as code. Automate all procedures by scripting and using frameworks like CloudFormation, Chef, and Puppet, and so on. Now, contracts between components should be well documented. Integrations rely on this documentation. As the contracts change, documentation should update automatically. This is to prevent integrations from misbehaving. When you change anything in production, make small reversible changes more often than big bang changes. These big changes have a higher risk of disrupting user experience and disrupting the business. Operations procedures, you should look at continuously refining them and making improvements wherever possible. Always anticipate failure, test failure scenarios, and the response procedures. And whenever there's a failure, learn from it. Conduct postmortems and understand what went wrong and how to prevent it in the future. The best practices are split into 3 categories: prepare, operate, and evolve. In the prepare category, what needs to happen is there has to be a shared understanding across business and development and operations. Workloads have to be designed with mechanisms to monitor application components, platform components, and infrastructure components, and also monitor customer experience and behavior. In this phase, you also have to create mechanisms to validate that workloads are ready for production and sufficiently supported by operations. In the operate category, you have to identify metrics for workload health and operations health so as to define successful operations. You have to define runbooks for well understood events and playbooks for unknown events. You have to prioritize responses to events based on business and customer impact. There has to be a well-defined escalation matrix of personnel, and there have to be dashboards to communicate operational status of the workload. When there are unplanned events, it's important to do an RCA that can be used to refine procedures. And routine operations must be automated. In the evolve category, you must continuously refine workload and operations. There should be feedback loops for continuous improvement, and best practices and learnings should be shared across teams. And there should be analytics on the metrics data to identify opportunities for improvement. And it's important to have the support for sandboxes for development and test environments. And overall, for the operational excellence pillar, the key product that enables a lot of the requirements is CloudFormation. It allows you to create systems based on templates and facilitates consistency all the way from development to production. For the prepare category, the key enabling AWS services include config, CloudWatch, CloudTrail, and VPC flow logs. CloudWatch facilitates a dashboard of metrics from all components, logging, including OS level info that can be logged in CloudWatch via a logs agent. For the prepare phase, these are the key questions that drive best practices. How do you determine what the priorities of your solution are? How do you make sure you design your workload so that you can have a visibility into its state? How do you ensure that the flow into production is minimizing defects and eases remediation if things go wrong. How do you ensure that deployment risks are minimal? And how do you know that a workload that is to go into production can be adequately supported? Now, let's look at the operate category. The key enabling services that facilitate smooth operations are CloudWatch, CloudTrail, X-Ray, and VPC flow logs. And the key questions that drive best practices for smooth operations are: how do you understand the health of your workload and the health of your operations? And as events arise, how do you manage those events? Let's look at the evolve category. The key enabling tools for this category is developer tools, which help continuously build, test, and deploy, and Elasticsearch tool for logs analysis. The questions that drive best practices for evolve category are, there's just one, it's how do you evolve operations? This completes the review of the operational excellence pillar. Let's move to the next pillar. The security pillar is about protecting your systems and your data by conducting conscious risk assessments and figuring out strategies to mitigate the risks. Let's look at key design principles for the security pillar. Strong identity foundation. This means key principles need to be followed. The principle of least privilege, the principle of separation of duties with appropriate authorization level for each interaction with your AWS resources, centralized privilege management, and reducing reliance on long-term credentials. Traceability is about auditing any change and any action to any environment and monitoring logs and metrics and taking automated actions when anomalies are detected. Security at all layers is basically the principle of defense in depth. Secure your edge, the VPC, subnets, load balancers, VMs, operating system. Automating security best practices. Always treat security as code. Describe security policies as declarative constructs. And all security controls should be in version controlled templates. And these controls include security groups, network ACLs, permission policies, etc. Protect data that is in transit and at rest using encryption, auth tokens, and access control mechanisms. As far as possible, avoid people directly handling data. Use tools, use mechanisms to handle sensitive data. And expect and be prepared for security events. Detect quickly, investigate, and recover. Now let's look at best practices. Identity and access management. Only authorized and authenticated entities should access resources. The entities could be humans or systems. Make sure you have well-defined principles, which include users, groups, roles. Make sure you have policies, which are permissions associated with principles. There should be a strong password policy and multi-factor authentication wherever you can. Look at identity federation instead of replicating identities in multiple places. Leverage the security token service that provides temporary credentials. Protect your credentials such as passwords and keys and tokens. For detective controls, always sniff for potential security threats as part of governance, and this may also be necessary for legal or compliance reasons. Process logs and events, monitor metrics, that means auditing, automated analysis, and alarming. Also stay up to date with security best practices as new threats evolve, and implement controls to detect and respond to these threats. Protect your infrastructure. Make sure you use controls to have defense in depth. Understand stateful and stateless firewalls. Protect your boundaries. Always monitor the points of ingress and egress and have comprehensive logging, monitoring, and alerting. Harden your EC2 VMs, ECS containers, elastic beanstalk instances, and whatever you come up with through a hardening exercise should be persisted immutably in an AMI. For data protection, classify your data and establish appropriate access controls and retention controls for each class of data. Encrypt your data at rest and in transit. Make sure you understand and use key management functionality and use rotation. You need to have detailed logging for access as well as any changes to data. Make sure you rely on exceptional durability of stored data. Durability is important for data protection. And use versioning of data to protect against accidental deletes or overwrites. For incident response, know that despite preventive and detective controls, incidents may still happen. The architecture must help with effective incident response with features such as the ability to contain and isolate systems quickly and bring systems to a known good state quickly. Keep in mind that automated response is really important when there are security incidents. And remember that CloudFormation enables forensics in a clean and isolated environment. The foundational service that is a key enabler of security is the IAM service. Now let's look at each of the best practices in a little bit more detail. For identity and access management, the key services are IAM, which is identity and access management, and multi-factor authentication, and organizations. Organization helps with centrally managing policies for multiple accounts. Let's look at the key questions that drive best practices. How do you manage credentials and authentication? How do you control and keep track of human access? And how do you control and keep track of programmatic access? For detective controls, key enabling services are CloudWatch, CloudTrail, Guard Duty, and Config. CloudWatch can trigger events to automate security incident responses. Config has a detailed inventory of resources and configurations. Let's look at the questions driving best practices. How do you detect and investigate security events? And how do you defend against new and emerging security threats? Let's look at infrastructure protection. The key enabling services are VPC, CloudFront, Shield, and Web Application Firewall. Shield helps with distributed denial of service attack mitigation, and it's deployed on CloudFront. Web Application Firewall can be deployed on CloudFront or application load balancer, and with it you can define rules to decide what traffic is allowed. The questions that drive practices: how do you protect your networks, and how do you protect your compute resources? For data protection, key enabling services are data encryption, MACI, and the key management service. The questions driving behavior: how do you classify your data? How do you protect your data at rest? And how do you protect your data in transit? Incident response, key enabling services are Identity and Access Management Service, CloudFormation, and the Lambda service. CloudFormation is very useful for creating clean, isolated environments for forensics related to security incidents. The questions driving behavior: how do you respond to an incident? This completes the discussion on the security pillar. Let's move on to reliability. Reliability is about minimizing failures, and when they do occur, recovering from the failures. And the failures could be in the application or the infrastructure. It's important for good reliability to dynamically acquire resources to meet demand, as opposed to statically acquiring resources, which may lead to undercapacity or overcapacity. Now, let's look at key design principles related to reliability. First, test your recovery procedures. Inject failures in your environments or simulate failures to test recovery to see how your application recovers. Ensure that recovery from failures is automated. Monitor metrics and initiate action when thresholds are breached. Ensure that the notification of failure to humans or systems is automated and that the failure is tracked in an incident system until it's resolved. With predictive machine learning, one can even preempt failures before they occur. Scale your system horizontally to increase availability. Avoid using monolithic resources and try to break it into smaller resources to reduce the impact of failure. You should never have to guess the capacity required for your application. Under provisioning causes resource saturation and increases failures. The cloud allows dynamic capacity management, so leverage that. Manage change and automation. So any changes to infrastructure should be automated. There are plenty of tools to help do that. Now let's look at best practices. First, establish solid foundations. Use service limits to prevent accidental runaway provisioning. Make sure there's governance in place for appropriate limits for the workload and monitor these limits. Ensure that a proper network topology is in place, and this includes connectivity within and across on-premise, public, and private. This includes IP address management and name resolution. Now, there should be effective change management processes. Respond to changes in demand automatically. Monitor logs and metrics. And when thresholds are crossed, self-heal or raise an alarm. And any change to systems must be controlled via a process to ensure predictability and recoverability. Failure management. Now, failures are to be expected in complex systems. The key is to detect, respond to, and prevent recurrence of these failures. And some good practices include, instead of trying to repair a failed resource, just create a new one and diagnose the old one in parallel. Backup data and environment configurations to improve the time to recovery and the recovery point objective. Architect the workload for resilience and distribute it to withstand outages. Make sure you test failures in your test environments and have a disaster recovery plan with designated objectives for the time to recovery and the point to which you can recover, also called RTO and RPO. And the key service that enables the achievement of the reliability pillar is CloudWatch. Now let's look at foundations. The key services enabling the foundation step are IAM, VPC, Trusted Advisor, and Shield. And the questions that drive good practices are: how do you manage service limits and how do you manage your network topology? Let's look at change management. The key enabling services are CloudTrail, Config, Auto Scaling, CloudWatch, and Personal Health Dashboard. And the key questions driving best practices are: how does your system adapt to changes in demand or changes in load? How do you monitor your resources? And how do you implement changes in your system? Let's look at failure management. Key enabling services to help manage failures: CloudFormation, S3 and Glacier, and the key management service. The key questions driving practices: how do you back up your data? How does your system withstand component failures? How do you test resilience? And how do you plan for disaster recovery? This completes the discussion of the reliability pillar. Let's move on to the next pillar, performance efficiency. Performance efficiency is about two things. One is to use resources efficiently, the right resources for the right requirement. And the other is to maintain this efficiency as the technology evolves and as the workload evolves. Let's look at the design principles for performance efficiency. For advanced technologies, it's better to consume it as a service, rely on vendor-managed services rather than spending time on provisioning, configuring, scaling, backing up, etc. There's a lot of heavy lifting that goes behind building and operating a service. To avoid that, you can use managed services provided by AWS. Remember that you can go global in minutes. Going global helps lower latency and provides better experience for your end customers that are distributed across the globe. Use serverless architectures where feasible. Avoid running servers of your own. For example, you can host a static website on S3 without having to manage any servers. What serverless does is it removes the operational burden of managing servers and also lowers costs. Experiment to keep tuning your performance to the best possible situation. The cloud enables quick and easy creation and deletion of environments, and this facilitates experimentation. Ensure that the technology you're using is aligned to your use cases. So understand your data access patterns, for example, before deciding on what storage technology to use. Let's look at best practices for performance efficiency. Selection of resources. Now, resources are available in various types and configurations. Use switches to enable, disable options and decide which configurations to use and which types to use. Leverage managed services that are available with guaranteed performance characteristics. For example, DynamoDB single-digit millisecond latency at any scale. There are many reference architectures available out there. You can optimize your architecture by looking at the reference architectures and by using data from benchmarks and tests on these architectures. There are basically 4 main resource types to consider: compute, storage, database, and network. For compute, look at and compare VM instances, containers, and functions as a service. For storage, understand your access method, whether it's block storage, file storage, or object storage that you need. Look at your patterns of access, whether you need random access or sequential access. Look at your throughput required. Look at the frequency of access. Look at the frequency of updates, and also availability and durability constraints. For databases, consider the availability requirements, consistency requirements, latency requirements, and the query capabilities you need. For the network, keep an eye on latency and throughput and location of physical resources and the users. These determine the network topology you need and the features you need. You can use regions, placement groups, and edge locations to improve performance. And continuously review your selections. As new technologies and approaches become available, keep evaluating to determine if your architecture performance can be improved. As for monitoring, monitor the performance metrics from every component and trigger actions when performance thresholds are breached. Alarms can trigger automated actions on badly performing components. And run simulations of load in production and ensure that alarms and actions are working. For trade-offs, remember that sometimes these are necessary. For example, sometimes you trade consistency for performance, or cost for performance, or space for latency, etc. And a key service enabling all the practices related to performance efficiency is CloudWatch. It provides visibility into overall performance and operational health. Now let's look at selection. There's a lot of services that come into play when you're selecting the resource types and configurations. They are auto-scaling, the various options with the Elastic Block Store, S3 content delivery, transfer acceleration, the various RDS options, DynamoDB performance numbers, Route 53 latency-based routing, the VPC endpoints feature, and Direct Connect. The key questions driving best practices: how do you select the best performing architecture? How do you select your compute solution, your storage solution, your database solution, and how do you configure your networking solution? Let's look at review. The key enabling services for the review step are AWS Blog and AWS What's New. This helps you keep in touch with the latest developments, new features, new technologies that you can examine and leverage. The key questions to drive best behaviors: how do you evolve your workload to take advantage of new releases? Now let's look at monitoring. The key enabling services here are CloudWatch and Lambda. And the key question driving good behavior is, how do you monitor your resources to ensure that they are performing as expected? And finally, let's look at trade-offs and what helps you manage these trade-offs. Well, are these key services Elasticache, CloudFront, Snowball, and other products of the Snow family, and RDS read replicas. And the key question driving best practices is, how do you use trade-offs to improve performance? This brings us to the last pillar among the 5 pillars, cost optimization. Let's take a look at that. Cost optimization pillar is about delivering business value at the lowest possible price. And traditionally, design decisions have been made with, gut calls and a just-in-case logic instead of, upfront benchmarking to evaluate the design. And also traditionally, the design decisions remain static throughout the lifetime of the application. This leads to underutilized or under-optimized deployments that remain that way forever. The cloud allows initial cost optimization as well as ongoing cost optimization, and you should try and leverage that. Now let's look at design principles related to cost optimization. Adopt a consumption model. What this means is you pay only for resources that are in use and scale up and down automatically based on need and not statically based on forecasting. Measure the overall efficiency of your application. Measure the costs and use it as a baseline to optimize continuously. Avoid spending money on DC operations. The heavy lifting of DC setup and management, leave that to AWS and focus on your customers and your core business. Analyze and attribute your expenditure. Cloud enables accurate attribution of costs by the workload owners. This helps each team to optimize their ROI. And finally, use managed services to reduce your total cost of ownership. This helps you get rid of operational burden and save on costs and complexity. Let's look at best practices associated with cost optimization. Be aware of your expenses. Monitor and attribute costs to different organizations. This encourages behaviors that optimize costs. Use cost-effective resources. Right-size your resources for the workload. For example, a small server running for 5 hours versus a big server running for 1 hour. The small servers for 5 hours are likely to be cheaper. Use managed services, which come at a lower cost compared to self-managed services. Use the most optimal pricing options for the requirements. Leverage reserved purchasing and spot instance purchasing. Use appropriate services to reduce costs. For example, CloudFront reduces data transfer. RDS Aurora cuts database licensing costs. Match the supply with demand. That is, the resources used should be matched with the demand for the resources. Use auto-scaling to avoid over-provisioning, which causes wasted resources, or under-provisioning, which causes degraded performance and increases operational costs. The auto-scaling can be based on demand, it can be schedule-based, or it can be buffer-based. And keep optimizing your costs over time. This is in line with continuous improvement that applies to all the pillars. As new features and services are released, evaluate application to make it more optimal. Keep an eye out for new managed services as they can reduce total cost of ownership. Also, as the requirements of the application evolve, evaluate decommissioning of resources that are no longer needed. The key service, it is central to all the efforts for cost optimization, is Cost Explorer. Let's look at each of the best practices in a little bit more detail. For expenditure awareness, the key enabling services are Cost Explorer, which helps you track the spend and know where the spend is. Budgets, you can set up notifications if costs are not in line with your forecasts. Resource tagging helps you tag usage and costs with business and organizational info. So this helps with attribution. Cost and usage report, pricing calculator, TCO calculator. The questions that drive best practices: how do you govern your usage? How do you monitor usage and cost? And how do you identify and decommission unused resources? Cost-effective resources. The key enabling services are Cost Explorer, which provides reserved instance recommendations, Trusted Advisor and CloudWatch that help with right sizing. Aurora helps you remove database licensing costs. Direct Connect and CloudFront optimize data transfer costs. The questions that drive best practices. How do you evaluate cost when you select services? How do you meet cost targets when you select resource type and size? How do you use pricing models to reduce cost? And how do you plan for data transfer charges, which can be significant? Matching supply with demand. The key enabling service there is auto scaling. And the key question, how do you match supply of resources with demand? Optimizing over time. Key enabling services, AWS Blog and AWS What's New, and Trusted Advisor advises about underutilized resources and gives recommendations on reserved instances. The questions driving good practices. How do you evaluate new services? This brings us to the end of discussion, all the pillars. Now let me quickly summarize the paper from my perspective. While the well-architected framework is outstanding at providing structure to designing and architecting cloud solutions in a reliable, repeatable way, there is a vast amount of information to look at. There's a large number of design principles and best practices and questions driving the best practices. And at times, the line between design principles and best practices is kind of fuzzy. So what I'm attempting to do here is to tell you about the key takeaways from this entire paper from my perspective in a succinct form. Let's take a look. The key areas to think about are scalability, security, cost management, automation, thinking about failures, monitoring of logs and metrics, making any changes to production, managing that well, and refining continuously. For scalability, understand horizontal versus vertical scaling and try and horizontally scale your application whenever you can. Understand stateless versus stateful components. Try to steer towards stateless components if you can. Look into distributed processing. Look at asynchronous integrations and event-based architecture. For security, you need to have a very strong authentication and authorization framework. You need to have defense in depth. You need to have separation of roles, among other things. But these are the key ones. For cost management, the key things to keep in mind is attribute your costs and monitor your resources to reclaim unused ones quickly. Auto scale up and down based on actual needs. Switch to cheaper resources through policy-based automation, for example, S3 storage classes. Use managed services, go serverless, and avoid managing data centers. Automation cuts across all the pillars, and think of automation at every level in your architecture and at every component. So some of the things to look at are build, test, deploy, and config management should be automated. Responses to operational incidents, environment setups should be automated via CloudFormation. And switch to optimal resources via policy-based automation. And documentation that's generated for the components should also be an automatic process. Failures. Always anticipate failures and be prepared, especially for security-related failures. Test your application with failure injection, simulate failures, implement self-healing where possible, and offload failure management where possible. Have well-defined ops runbooks, playbooks, and escalation paths, and have well-defined data backups and disaster recovery procedures. Monitoring is essential to many of the pillars. So what it does is it enables quick responsiveness and diagnosis. It can detect performance and security issues and trigger automated actions. It can detect user experience issues and trigger automated actions. Change management in production is important. Have readiness assessments and checklists before anything is launched in production. Make frequent small and reversible changes. Test failure scenarios and recovery in those scenarios at production scale, and deploy safely and securely to minimize disruption to users in case of failures. Refine continuously again applies across all the pillars. So operations procedures, learn from failures, have postmortems, and refine continuously that way. Refine your architectures continuously, measure the performance, measure the cost, fine-tune, watch new technologies and new features to keep refining, keep experimenting and innovating because the cloud makes it easy and it makes business sense, and stay current with new security threats so you can keep refining and strengthening the security of your application. So this brings us to the end of the paper. Thanks for watching the video. If you found it useful, please consider clicking on the like and subscribe buttons. If you can leave a comment about what you liked and what could improve, I would really appreciate that. Thanks again.